The industry has moved past simple AI autocomplete. We are now deploying autonomous agents designed to handle full-stack orchestration from the initial prompt to the final deployment. We expect these systems to manage database connections, handle package installations, and navigate through raw build errors. Agents rely on a context window, needing foundational rules at its base. But expanding this space to millions of tokens fills it with terminal logs. This increases costs, and the heavy logs bury core instructions, causing the AI to forget the initial variables. Failure in these systems stems from a poor signal-to-noise ratio. The operational junk generated during execution eventually buries the baseline logic, making successful long-term navigation impossible. After an agent runs for hours, it produces a massive trail of text, much of it consisting of failed attempts and technical trace logs. As logs accumulate, the agent's internal model becomes incoherent. It can no longer distinguish a core architectural rule from a transient terminal error. This is memory decay. Once the AI is overwhelmed by its own logs, it forgets the initial architecture and begins to hallucinate code that was never part of the original design. Xiaomi's MiMo code offers a different approach. Rather than continuing the trend of expanding context windows, it utilizes a framework designed to manage information more efficiently. MiMo mimics human neurobiology, specifically the cognitive function of sleep, to prevent the agent from becoming overwhelmed by data. The human brain does not retain every sensory detail of a single day. It sleeps to discard useless noise and consolidate essential lessons into long-term memory. Reliable autonomy requires this same kind of aggressive memory compression. An agent must be able to forget the irrelevant to remember the essential. MiMo code does not rely on a single AI model. Instead, it deploys a coordinated team of specialized sub-agents to handle different parts of the engineering process. When you provide a prompt, the system triggers a candidate evaluation pipeline. Multiple sub-agents work in parallel to generate competing logic pathways. A dedicated evaluator agent reviews these proposals, identifies errors, and selects only the optimal route. This internal debate mirrors the process of a senior engineer reviewing a junior developer's code before it ever reaches production. By filtering logic before execution, MiMo prevents architectural errors from being written into the project, stopping hallucinations at the source. While many AI tools live in VS Code sidebars or web interfaces, MiMo code is designed to operate natively within the terminal. Autocomplete assistants belong in a GUI where they wait for human clicks. An autonomous agent, however, requires an environment where it can act without a middleman. True autonomy requires specific terminal privileges, installing packages, managing Docker containers, and executing Git commits independently. The agent must also read raw bash error logs directly. It cannot wait for a human to copy and paste the terminal's output into a chat window. This environment allows for a continuous feedback loop where the agent executes, reads the result, and iterates in milliseconds. Placing an agent in a limited interface blocks its ability to troubleshoot. For complex engineering, command line supremacy is a necessity. After hours of execution, the agent's context window is inevitably saturated with thousands of lines of chaotic debug logs and failed attempts. To clear this, you execute the /dream command. This forces the agent to pause its task and enter a state of memory compression. During garbage collection, MiMo discards useless error logs and failed logic paths. It distills only the successful logic and the exact commands that worked, saving them as a deterministic logic map, a file known as skill.md. This shifts the AI's behavior. Instead of relying on the probabilistic guessing of a language model, the agent begins following a rigid, proven script. If you ask the agent to deploy a Docker container today, it will work through the process of discovery and troubleshooting. But on the second day, the agent no longer needs to guess. It reads the skill.md file and executes the exact bash commands for your environment with zero chance of hallucination. The dream state solves the amnesia problem by turning a noisy, chaotic history into a structured execution script that the agent can follow indefinitely. There is a common misconception that because the MiMo code framework is open source, it is financially free to run. The software itself has no licensing fees, but it requires a connection to a large language model API. Those providers charge for every token the agent consumes. Because autonomous agents are incredibly verbose, reading files and writing code constantly, they consume tokens at a massive rate. A single intense session routed through a premium model like GPT-4o can result in hundreds of dollars in API charges in a very short time. To manage this, MiMo is model agnostic. This chart compares API cost efficiency. Engineering teams can drastically reduce costs by routing through affordable APIs like DeepSeek Coder v2, offering high proficiency at a fraction of the price. For total privacy and zero API costs, developers can run local models like Llama 3 through Ollama, using their own local GPU compute instead of a cloud service. The viability of an autonomous agent in a professional setting depends as much on its token routing economics as it does on its ability to write code. We are seeing a transition in how software is built. Reliability isn't just about the sheer size of the neural network. It's about building smarter cognitive architectures that can consolidate and manage memory. This changes the role of the developer. You are moving from a manual writer of syntax to a system orchestrator overseeing multiple autonomous entities. If you are a senior developer, you should observe this process firsthand. Assign MiMo a contained task to see how it manages the multi-agent debate and the dream state in your own terminal. The developers who master the orchestration, budgeting, and optimization of these autonomous systems will be the ones equipped to build at this new scale.